All right, how's it going, everyone? My name is Sam Welker, and this is Cosmic Sandbox. And today, we're going to be making a recreation, sort of the cloner tool in Cinema 4D, uh, or from Cinema 4D, I should say, in Blender. This is not a complete copy. This is a very complicated tool. It's very powerful in Cinema, and to recreate this would take an exorbitant amount of work. But we're going to be recreating some of the cloning options. So in Blender, you do not have the clone tool. You don't have a way to clone objects onto meshes using like the array modifier or something like that. You need to use something like the geometry nodes. So the way to do this in Cinema is to have something like a sphere, and then to clone an object using the cloner object onto the actual geometry. You can do this on per face, random faces. You can do this per vertex. Today we're just going to focus on the actual face variation though. So this is what it would look like in Cinema 4D, and this is what we're going to be recreating. This is really, really useful for layout and other sorts of approaches like that. So this is something I've been trying to figure out in Blender for a little while. I've been using it as a modeling tool for the last week, and I think Blender is super cool, super impressive, and it has a lot of work to go in a lot of areas. But I definitely think it's worth using. So what we're going to be doing is using geometry nodes to recreate this. Now, there are a lot of tutorials out there that explain how to do this. They're all using the alpha version or a previous version of Blender. Not 3.0, but 3.0 alpha or 2.9 or something like that with geometry nodes. And this is one of those issues where Blender's inconsistent. It's because it's I don't want to call it a hobby project, but it is more of a hobby project. It is an open source software that doesn't have to stay consistent, which creates a lot of value, but can also create some inconsistencies. And this is one of those inconsistencies. The nodes are different from 2.9 and 3.0 alpha into the actual 3.0 release. So what we're going to be doing is going in and using the 3.0 version and creating this example. So let's go ahead and split the window here. We're going to go ahead and turn on the cloner geometry that I've created. We're going to turn off these two, and we're going to create a geometry node editor window here. I'm going to hide it. And this is the sample of what we're going to be creating. Okay, so this again is our sphere that we're going to be cloning onto. This is actually going to be cloning onto the vertex points. I had said this is going to be onto the faces. That is not actually correct. Let's see if I can do that. It is, yeah, no, this is going to be onto the actual points for this instance. We'll address, onto the actual faces another time potentially, but for now, this is going to be on the actual vertexes. So apologies for that inconsistency there. And then this is the cube that we're going to be using to clone. The actual cube is hidden right now, but that's just a sample of what we're going to be using. And what we're going to create is a node tree that uses the instance on points to instance the actual points, and then we're going to convert that to instances or realize the instances to convert it to geometry so we can actually edit it. But the issue I had with this is actually getting the normals of the geometry for the cloning. If you just go ahead and clone the objects onto the sphere, you won't get the normals of the geometry you're cloning onto, and that is not ideal. So I'm going to show you two ways to do this. We're going to use the random way, which gives us the random placement, and then we're going to use the actual vertex way. So let's go ahead and break it down. Let's go ahead and take the reference sphere and the cloning cube, and we're going to just duplicate them. That actually has to be visible to be duplicated. Again, a little bit new to Blender, but definitely very happy to be here. All right, so we're going to have our cloning cube and our reference sphere. The little cloning cube is right here, and our reference sphere is here. And this is just a low resolution of the quad sphere from, I think, Mesh Machine or Mesh something. One of the mesh tools, the machine tools. And what we're going to do is we are going to create a plane object here. And this is going to be our geometry nodes. And we're going to go ahead and add the modifier geometry nodes here. And then what we can do is we can just uncheck that. So let's hide the cube, or yeah, the cube and the sphere, and the geometry nodes is all we're going to see. And in geometry nodes, when you get started, if you unlink the geometry here, then it will no longer show the original plane. So, it doesn't really matter what the original geometry is. So what we're going to do is we're going to grab the reference sphere and the cloning cube. And these are what we're going to clone on, right? So the cloning cube, let's see, which one is which? Cloning cube is the bottom, the reference sphere is the top. Okay, cool. So we're going to start with just instancing onto the actual points, okay? So we're going to use the instance right here, which we're going to go ahead and add an instance on points. And if we instance on points using the cloning cube, so this is going to be the instance geometry, onto the reference geometry, which is the points, and then just put that into the cube here. The first thing I want to do is use relative so that I actually inherit the transform that I used to scale the geometry nodes, or excuse me, to scale the cloning cube, because I scaled it in object mode, not in edit mode, so it has actual it has actual transforms applied to it in the delta transform, which is basically like freeze transformation from other software. So if you don't know what that means, don't worry about it, doesn't matter. But the relative option allows you to inherit the actual transform data there. So this is the instance onto points. And as you can see, this is not matching the direction of the points on the sphere. So what we want to do is we want to grab the normals of this. And the way to do this is to get the node normal. And you can hit Shift A to bring this up. I switched it to tab. So, if you see me screen recording this in the future and it says tab, that's what it uses there. Because I'm so used to that from every other node editing software ever that I'm not quite used to Shift A, and it kind of throws me off. But anyways, we're going to go ahead and use that, and then we're going to get another node, and this is going to be Euler. Align Euler to vector. And we're going to go ahead and drag the normal into the vector, and then the rotation into the rotation. And we're going to align the z-axis. All right, and I want to do a quick little bit of housekeeping here. This was something that I picked up from this tutorial here, Bradley Animation. This is a newer tutorial. This was very helpful. We're going to be taking this a little bit of a different direction, so I did feel like it was okay to make another tutorial here, but Bradley did a great job with this. Go check this out. He has a lot of great geometry node tutorials. And again, it's just Bradley Animation. So yeah, thank you, Bradley, for helping out with that. All right, so that allows us to actually align the points to the normals. Now you could look at this and see that they're not quite exactly the direction we want them to be facing. So what we're going to do is get an instance rotate node, or a rotate instances node, and just drop this here. And then we can just go ahead and rotate the instances individually using the rotate instances node, which is super helpful. If we wanted to rotate them on the z-axis, they'll spin. This is something that helps you to place all of the instances or rotate them. And if you wanted to do something like translate, you could also move them in and out. And this is a really, really handy way to place and move each individual instance. So if you're in something like Cinema 4D, this would be similar to the transform options here, like so and like so. So this would individually rotate each item. So that is how we place these on the actual geometry here, right? And you're noticing I'm not using the group input here. This isn't actually important. I did have it set up in the other variation, if you saw, just for some handy cleanup, but that's not very important if you're not using the original geometry or making some like shortcuts in the modifier here in the attributes. So this is great. This is useful, but if we make this editable, we still get our plane. So what we want to do is use the realize instances node. And now if we hit tab and go into edit mode, we still have the plane. But if we were to convert this So let's do convert mesh. Now our node is gone, by the way. But if we convert this, now we can actually see. Let me turn off the normals here. Now we can see that we can actually edit the geometry. So if I undo this and go back, let's get rid of the realize instances node and again convert to mesh. All right, and everything is gone, right? So you need to use the realize instances node. Sorry, still not quite used to the keyboard shortcuts here. Getting used to them. All right, so that is how you place these on the actual vertices. So this is really helpful if you wanted to create like a cloner object, grid array, something like that. You could use a plane object and then just align it vertically a few times, and that could give you a way to create a cloned set of geometry, which is very, very important in layout, at least in my workflow. So that helps a lot. Let's go ahead and take these, and we're going to duplicate this and pull it up just using the Shift D key, and we're going to drop this in to the geometry. We're going to use the random variation now, okay? So we're going to use a, let's see, points, distribute points on face, and this is going to give us a random set of points to distribute onto the actual faces, and we can use this to do something like so. All right, so this is a random set of points on the same sphere as earlier. It gives us a sphere and the random positioning on the actual faces for Cinema 4D by just using the surface variation. Instead of polygon center, you're using surface, and then you can just tweak the seed and things like that. We're going to create something like this in Blender using distribute points on faces, and we're going to grab the reference geometry, type that in as the mesh, and then we're going to just put these points onto the instance on points, and then grab the original geometry, the instance, and pump this into instance on points. Now you can see that we have our normals again, all screwed up. And we have a lot of these. Let's go ahead and set this to 1 on the density to have less. And we're going to grab the rotation here and put that on to the rotation. Now, you'll notice that this looks like it's lined up, but it doesn't look very smooth. We're actually going to use a different quad sphere for this. So let's create a quad sphere, and then let's turn up the rotation because this is going to give us a little bit of a smoother alignment. You can see that the original, let's see, it's not that one, it's this one. This sphere only has, a few polygons on each side, and they're very, very specifically aligned. And you can actually see that the rest of the geometry here lines up to these points. So what we're going to want to do is use a higher polysphere, this one, and we will go ahead and drop this in here. Let's just drop it in right here. This isn't actually lining up. Right, there we go, okay. And if we drop that into the actual mesh, you can see it's a lot smoother now. It looks like it's actually coming out of a circle instead of something a little bit more deformed. And if we change the seed and the density, we can get some different looks here. But this gives us kind of a random distribution onto these instances, onto the actual original sphere. So one thing that's really useful, and this is an effector in Cinema 4D that you can use, is the push apart effector, right? It has the ability to push points away from each other so that they don't overlap. So a great sample of this, sorry, I keep on mixing up my shortcuts here. A great sample of this is to push apart all of these overlapping cubes. So the push apart effector works really well with that. It doesn't keep it on the actual geometry in this instance, but that's totally fine. But we will be keeping it on the geometry here. So we're going to use the poison disk method, and this is intense. It's going to be very, very thick, but this helps keep it a lot more distributed. So what you do is you have the density factor on the mesh, and you pull up the density max and up and down the density minimum. So if you want things close to each other, you can just keep density minimum at a 0 and they can overlap. But if you turn that up, it will get rid of points that are too close. That's actually something you can do also with the push apart effector, which just hides points that are too close. So if they're overlapping, you can just use the hide method. So this is kind of similar, but you don't have to hide them. Instead, it actually just gets rid of the points. It's a little bit more like the scatter node in Houdini, if you're familiar with that. So this is also able to be driven by the density factor and the seed, which is super useful. This is great for just aligning random positions on the geometry. And it is exactly what you would want if you are going to be randomly placing a lot of objects in the scene and not just using an array effector. In fact, actually, I don't even think the array, excuse me, not effector. I don't think the array modifier even lets you randomly place things, but this is super useful. This is a very practical application of geometry nodes instead of something just kind of fun and, glitzy. It's, you can do some cool stuff with geometry nodes, but this is like a super practical, very like day-to-day work kind of example that geometry nodes really shines. So it took me a little while to figure this out. This wasn't very intuitive, so I figured I would make a little video, and hopefully this was helpful to you. If you have any questions, leave them down below. I'm sure this will probably change in the future, and if it does, maybe I can make an updated video. Thank you so much for watching, guys. I appreciate your time, and I hope you learned something. So again, a quick shout out to Bradley Animation for creating a very similar video. A very helpful explanation of this. He goes into a lot of different detail and a lot of other explanations, but I figured I would go ahead and create a variation explaining how to recreate some effects from Cinema 4D, because there's a lot of questions on Google about that and not a lot of answers. So thank you for your time. Make sure to leave any questions below. Hit the like if this helped you, the like button, and make sure to subscribe for more future videos with Blender, Houdini, Cinema 4D, etc. So have a fantastic day, and I'll see you guys next time.